Hi, this is Osama Al-Amrani, and today we dive into the world of halogens, those intriguing elements in Group 17 of the periodic table. These 5 vibrant elements, fluorine, chlorine, bromine, iodine, and astatine, are known for their unique characteristics, reactivity, and their interactions with other elements. From their varying colors to their distinct reactions with alkaline metals, nonmetals, gases, and metalloids, we're about to explore the fascinating universe of halogens. Ready to embark on this halogen adventure? Buckle up. First stop, fluorine, the most reactive of all the halogens. This pale yellow gas is the lightest member of the halogen family, and boy, does it have a temper. Thanks to its 7 outer shell electrons itching for a partner, it doesn't play nice with others. It reacts vigorously with virtually every other element, be it an alkaline metal, non-metal, gas, or metalloid. Picture this: fluorine meeting an alkaline metal. It's like a whirlwind romance. They bond instantly, creating a salt. But don't let the name fool you. These aren't your kitchen variety salts. They're a whole different kettle of fish, often used in batteries and other industrial applications. Now bring in a non-metal, say carbon. They form a bond stronger than a superhero team-up, creating compounds that are incredibly stable and resistant to heat, chemicals, and electricity. These compounds are often used in high-performance plastics. And gases? Oh, they're not safe either. Fluorine can bully noble gases into forming compounds, a feat once thought to be impossible. What about metalloids? Well, when fluorine and silicon get together, they create silicon tetrafluoride, a compound used in glass etching and ceramics. But it's not all chaos and reactivity. Fluorine has a softer side too. It's a key ingredient in toothpaste, giving us those pearly whites. And it's also used in rocket fuel, helping us reach for the stars. Despite its reactivity, fluorine has some amazing uses, from toothpaste to rocket fuel. Our next halogen on the list is chlorine, famous for its role in keeping our swimming pools clean. Yet there's so much more to this fascinating element. Chlorine is a greenish-yellow gas under normal conditions. It's heavier than air and has a rather unpleasant, pungent smell, quite like bleach. That's because bleach is a solution of sodium hypochlorite, which releases chlorine gas when mixed with certain other substances. In terms of reactivity, chlorine is a bit calmer than its sibling fluorine, but don't be fooled. It's still pretty eager to bond with other elements. It's also diatomic, which means it prefers to hang out in pairs, forming Cl2 molecules. And what about its interactions? Chlorine reacts vigorously with alkaline metals. When it encounters sodium, for instance, they combine to form sodium chloride, table salt to you and me. With nonmetals, the reaction is generally less intense. For instance, when chlorine and hydrogen meet, they form hydrogen chloride, a colorless and corrosive gas. And when chlorine reacts with metalloids, it typically forms covalent compounds. Silicon tetrachloride, a fuming liquid produced when chlorine reacts with silicon, is a prime example. Chlorine is not just about keeping our pools sparkling though. It's also crucial in the manufacturing of a wide range of products, from paper to paints, and from textiles to pharmaceuticals. From disinfecting water to manufacturing plastics, chlorine sure keeps the world turning. Moving on, we encounter bromine, the only liquid halogen at room temperature. Bromine, with its symbol Br and atomic number 35, is a fascinating member of the halogen family. This halogen stands out literally with its distinctive brownish-red color. It's a sight to behold, but remember, safety first. Bromine can be harmful and requires careful handling. Bromine is less reactive than chlorine and fluorine, but more so than iodine. It has the characteristic of being a good oxidizing agent like its halogen siblings. It's interesting to note that bromine's reactivity allows it to engage with a multitude of substances, making it indispensable in many industrial applications. Let's delve into bromine's reactions. When bromine encounters alkaline metals, it produces bromides. For example, when it reacts with sodium, sodium bromide is formed, a compound used in medicine and as a sedative. Bromine also reacts with nonmetals such as phosphorus to form phosphorus tribromide, used as a reducing agent in organic synthesis. Bromine even reacts with metalloids. When it comes into contact with silicon, for instance, it forms silicon tetrabromide, a fuming liquid used in the manufacture of synthetic fibers. Bromine might not be as well known as its siblings, but its contributions to photography and flame retardants are invaluable. From the color of your photographs to the safety of your homes, bromine quietly plays a vital role in our lives. Meet iodine, the heaviest stable halogen and an essential nutrient for our bodies. A fascinating element indeed, iodine is unique with its striking violet color that sets it apart from its fellow halogens. This color is due to the absorption and emission of light in the visible spectrum, making it a sight to behold. Iodine is less reactive compared to its halogen siblings, fluorine, chlorine and bromine. However, don't let this fool you, as it still forms compounds with a range of substances. When it comes to alkaline metals, iodine reacts readily, forming salts known as iodides. For example, iodine and sodium react to form sodium iodide, a compound used in everyday items like table salt. Moving on to nonmetals and gases, iodine's reactions are diverse. With hydrogen, it forms hydrogen iodide, a colorless gas that fumes in moist air. As for metalloids, iodine reacts with silicon, forming silicon iodide, a compound used in the manufacture of semiconductors. But iodine's significance doesn't end in the lab. It's an essential part of our nutrition, required for the normal functioning of the thyroid gland. It's also used in medical treatments, like disinfecting wounds, and in certain diagnostic procedures. From medical treatments to nutrition, iodine impacts our lives in more ways than we can imagine. Last but not least, the rare and radioactive astatine. Unlike its colorful halogen siblings, astatine prefers to keep a low profile with its almost black color. It's the heaviest halogen and, intriguingly, the rarest naturally occurring element on Earth. Astatine's reactivity is a bit of an enigma. While it's part of the halogen family, it doesn't behave quite like its relatives. It's less reactive than iodine, its immediate predecessor, but don't let that fool you. It still has enough vigor to react with many substances. For instance, when astatine comes into contact with alkaline metals, they react to form salts. These are not your everyday table salts, but rather, they're radioactive salts. Fascinating, isn't it? And when astatine encounters nonmetals, it forms covalent bonds, similar to iodine. But here's where things get really interesting. Astatine's interaction with gases and metalloids is less understood due to its scarcity and radioactivity. However, what we do know is that it can displace iodine from iodine-containing compounds, hinting at its potential reactivity. Now you might be wondering, what's the use of such a rare and radioactive element? Well, astatine has a significant role in the medical field. It's used in targeted alpha particle therapy, a type of cancer treatment. Though rare, astatine's potential in cancer treatment is a clear testament to the power of halogens. We've journeyed through the halogen family, from fluorine to astatine. Let's take a moment to recap what we've learned about these fascinating elements. We kicked things off with fluorine, the lightest and most reactive halogen. This pale yellow gas is incredibly eager to react with almost anything it encounters, including glass and steel. It's this reactivity that makes it so useful in our everyday lives, from non-stick pans to toothpaste. Next up was chlorine, the second lightest halogen. It's a greenish-yellow gas that's less reactive than fluorine, but still pretty feisty. We talked about how it's used to purify our water and keep swimming pools clean, all thanks to its ability to kill bacteria. Bromine was next on our halogen tour. It's the only liquid halogen at room temperature, and it's a dark reddish-brown color. We discussed its use in photography and how it's less reactive than both fluorine and chlorine. Then we dove into iodine, a solid halogen that's a beautiful violet color when it's heated. It's even less reactive than bromine, but it's still pretty handy. We use it in our bodies to make thyroid hormones, and it's also used as a disinfectant. Finally, we wrapped up with astatine, the heaviest and least reactive halogen. It's a rare radioactive element that's often used in cancer treatment. Astatine is so rare, in fact, that it's the least abundant naturally occurring element on Earth. Throughout our journey, we've seen how halogens react with alkaline metals to form salts, and how they react with nonmetals to form molecules. We've also explored their reactions with gases and metalloids, further highlighting the versatility and importance of these elements. Whether in our toothpaste, our swimming pools, our cameras, or even in our bodies, halogens are everywhere. Thanks for joining this halogen journey. Stay curious.